Okay. Okay. Welcome to another episode of our HDF5 clinic. It's 1 o'clock Central, and interesting enough, we had some questions, although that this question was a little bit like a future variable. Whoever asked the question said that unfortunately they would be unable to attend today's event. So what I'm going to do is, they said they would be able to attend next time. So I will come back to these questions next time. I'm just going to give sort of a few pointers and quick answers today, but then we will sort of get into this in depth next time. That would be June 1st, I believe. And the questions that were asked, the first question that was in reference to something I believe we spoke about last time. We mentioned sort of experimenting with chunking and compression and so forth, and pointing out that there are some, either use some high-level language bindings like H5Py or Julia or H5CPP. But then also there is a command line tool that we'll talk a little bit more about today, called H5 Repack, as a very convenient way to explore how you can maybe compress your data, transform your data, take advantage of different features in the file format and so forth. And so the question was, does H5 Repack have any impact on reading? And the way I understand the question is, so let's say you have produced an HDF5 file, and now you apply some kind of transformation, you repack it, so to speak, in some form. Does your read performance potentially change as a result of that? And the answer is yes. That can definitely happen. It can happen both ways. Your performance might be better as a result, or your performance might be worse as a result, depending on how you read the data. And that's also related to the second question. So let's say, for example, you applied compression, and applying compression was pretty successful. So your file, let's say, is now in a lucky scenario 10 times smaller. And well, that would mean for read performance, first of all, that you typically, assuming you're reading data sets beginning to end, that you would read, roughly speaking, only 1/10 of the data. So your pure I/O time, one would think, would shrink proportionally or somewhat correlated with that compression ratio. And so, but then of course, it's not purely I/O time that you are looking at, because of course you're reading less data now because the data is compressed. However, you will have to uncompress that data in memory, and that will take time, depending, for example, with an algorithm like gzip, the compression level that you chose. If the compression level is rather low, so the compression levels go from 0 to 9, 0 would be no compression, 1 would be the lowest, 9 would be the highest. So the CPU intensity or would be lowest with 1 and higher with 9, and in between for the rest. So you will spend some time, CPU time that is, to decompress the data, and you will notice that in performance. So, but potentially there are some gains there. But then of course, you could be unlucky, and it's not only that you can go from, let's say, uncompressed to compressed, you can also go the other direction. So if you think you're reading large data sets, typically contiguous large ranges of your data, there's no real advantage in chunking potentially in this case. So you can unchunk, so to speak, your data set, and then you might see better performance potentially. Or if your chunk size, let's say, was too small, you have a lot of overhead, space-wise and time-wise. Turning it into a contiguous data set might be beneficial, or if the data set is very small, less than, let's say, 64 kilobytes roughly, you compact your data set, that might give you a speed improvement. But yeah, it can go either way. And so the answer is definitely yes. And there is a difference between compression and uncompression. Yes, definitely, for the simple reason that you take two very different code paths in the library. Reading a chunk data set is very different from reading a contiguous data set. And I included a link here. There's actually a very nice write-up available as part of the documentation. It's called the H5 data flow pipeline for H5D read. If you are more interested in write, well, then I can find another paper where this is covered. But if you use your imagination here, write is sort of doing what you do with read in reverse. And the similar ideas apply. So in this document, we talk about, well, first of all, the layout in the file and what happens when you read something that is not perfectly aligned with chunks and there are overlaps. And then there is a very nice diagram here. So here's something about the layout, but then the flow graph, if you wish, of the whole read activity is laid out nicely here. So you're calling H5D read, reading a chunk from the file, depending on if there's only one filter or if there are multiple filters or no filter at all. You will spend some time here. So you can read filter as compression in this case, but there are other filters that are not compression that for which this flow applies equally. And then there's a question, is there a data type conversion or value transformation involved? If not, then this whole thing is bypassed. If there are data type conversions or value transformation, there's more involved here. And then there is a question, is something the first chunk or not the first chunk, having to do with buffer allocation and so forth. So anyway, this is a very nice document that gives you a lot of technical detail on what's happening in the library behind the scenes for chunked reads, and then by extension for writes. And then the third question was around creating what they call figure of merit to measure, capture I/O improvements, then for different setups and so forth. What I would say is what's crucial here is really you need a baseline. You need a baseline and a metric, of course, or multiple metrics. Without a baseline, you have no case. There is no meaning of improvement or better or worse if you can't measure it, and if you do not have a baseline against which you can measure something, you are just sort of floundering. And so that's clear. Since the person who asked this question made reference to there are different configurations and different hardware, different setups, different storage tiers, whatever. We talked a little bit about this in the context of varying library parameters that are not metrics, that do not represent metrics in and of themselves, but that you could see as, what if I do this with an NVMe attached SSD versus a burst buffer versus a parallel file system? So sort of those are variables. On the YouTube channel, there is a recording of a webinar we had recently, and we sort of presented as one of the, I think, appropriate visualization techniques here called polar diagrams. And so in this video, if you jump to around minute 15, 18, 19 seconds, that's where we quickly describe what these polar diagrams are about, and then there are a few more examples after that. But that's sort of, for today, just a high-level response to that. Again, we'll come back to this next time on June 1st. Okay, before I continue, I want to ask, are there any other questions at this point? Otherwise, I'll just continue, and I'll pause many more times to see if there are other questions. So I take that as a no. Okay, so let's go through our usual routine here. Last week's highlights. We have some announcements. Number one, it's important. We were supposed to have a webinar this coming Friday. That was postponed, and stay tuned for a re-announcement. But yeah, it's important. Don't be disappointed if you come there and there's nothing there because it was postponed. So it won't take place this Friday. The other one is, yeah, we still have the call for paper and presentation out there. I believe, Laurie, didn't we extend that deadline? Is it June 15th now, or?
I believe we are going to, but of course it's always
okay. So we haven't announced that yet. So for the time being, pretend it's June 1st, although there might be an extension in the cards, and then the event itself taking place in October. Okay, another one, interesting discussion going on in the forum. This was, someone asked, they had that situation where they had a filter plugin dynamically registered, meaning you had a filter, I believe it was a compression filter in this case, that you just have in a shared library. And the question was, well, what do you do if you have a filter that has kind of state where you could think, well, as a compression algorithm sort of sees data, sees chunks sort of coming by, and then you apply that compression algorithm, let's say, to these chunks, there could be an element of learning involved, and you could ask, well, what if I would like to maintain this learning state somehow, to either take advantage of it as I go from chunk to chunk, or then in the end, I would like to take a snapshot of that and maybe store it somewhere else in the file. And it turns out that it is certainly possible to do. It's not very pretty, but it is possible. It's just a little, not necessarily for people who are just starting to use HDF5, and to explain why that is not as straightforward, let me quickly show you what's involved here. So if you are using such a filter, such a user-defined filter with the filter pipeline, what you usually do is you have to register that filter with the HDF5 library, with the instance of the HDF5 library that you're running. And there's a call here called H5Z register that you call. But before you can call H5Z register, you have to populate a structure of type H5Z underscore class underscore T. And you basically have to fill in things like the version, the filter ID, whether you can do both encoding and decoding or only one of the other. You provide a name, and then there are these three callbacks here that you have to provide. And ignoring the can apply and set local callbacks, the actual filter function that sort of does the work, the compression and decompression, is this filter field in this structure. And so in this case here, I just, the signature of that function is basically, it returns a size t, and it takes certain flags as arguments, and then there are parameters. There is a parameter array, and you provide the size of that parameter array. and all the parameters in that array are unsigned integers. And then you basically provide the buffer. That will be the buffer that contains the chunk, the data that you are supposed to either compress or decompress or to filter, more broadly speaking. And you can provide you can either replace that array. In some cases, you have to replace that array. For example, if it turns out that your filter actually increases, you need more storage than is available in this buffer that you can reuse. You would have to allocate a new array and then return that as part of this callback. And then, of course, inside of this filter function, by looking at this flags unsigned integer, you can detect the library basically tells you if you are reading data, or in the case of a filter, you decompress data, or if that flag is not present, you are actually writing data. So you are, for example, compressing data. And now the question coming back, so how in the context of this is all you have to work with. How would you maintain any kind of state information, this dictionary or this learning state, so to speak? And that's it's kind of a little awkward, but in the right direction, what you could do is you could look at this parameter array, these so-called CD values here. They are unsigned integers, and of course you can abuse that fact in a variety of different ways. So, for example, let's say you would like to pass the pointer to a structure to this function where you maintain that state. So you would have to, on this platform, look at how long is an unsigned integer compared to a pointer. So potentially you need multiple unsigned integers to represent a pointer on that architecture. But that's just one example of how you can kind of piece it together. It's a little hacky and it's not for the faint of heart, but it's certainly doable. Another approach is, of course, to use something like environment variables, and you could use these parameters, for example, to pass some information about the environment variables through this callback. So there are different options here, and it is an interesting question. Obviously, when this interface was specified, that was not on the minds of the people who created this interface. But I mean, if there are interesting use cases, then I think we are certainly open to revise some of these interfaces, and that might be something that could be more convenient in the future if it turns out that a lot of people say we would like to create user-defined filters that have to maintain some kind of state information, and they just would like a more convenient way, a more straightforward way, rather than doing awkward things like environment variables, global variables, or sort of piecing pointers or other data types together from integers. That's really awkward. And especially if you also think about wrappers or language bindings for other languages and so forth that may not have pointers or may not have this rather bit and byte centric view of their machine or their virtual machine. Anyway, I just thought I'd point that out. So this is an interesting discussion, and so if you are interested in that, you should take a look at that. Okay, time flies here, I can see. I'm going to pause once more and ask the question, are there any questions about HDF5, your application, anything related to this? Otherwise, I have something prepared in preparation for this next meeting when we sort of go deeper into those questions. And I want to talk a little bit about H5 Repack, what it can do for you and the kinds of things that you can do with it. Okay. Maybe there aren't any questions. Okay, so let's just look at H5 Repack. So I would call it, it's one of these tools where you can get a lot of stuff done without writing a lot of code, and that is often a good thing. The first thing I would do is check your installation, do a sanity check, just open a shell or command line window or something like that, and type in H5 Repack --help, and or even without --help. If you get command not found, well then probably it's not installed or it's not in your path or something. So you'll have to deal with that. But if it's found, then you will get output that looks a little bit like this. I've truncated it here, but it will tell you that sort of the basic syntax for H5 Repack is you have H5 Repack, then you have sort of a slew of options or very few options, and then basically you're dealing with an input and output file. I believe I should have tried this before this meeting, but I'll give you the answer next time. I believe the HDF5 library expects that the input and output file are different, just to be cautious and just to, if there is an error, to ensure that your input file is not corrupted as a side effect of sort of trying to do something. And so I believe that file 1 and file 2 have to actually be different. But I could be wrong on that. I'm going to try this and report next time, but my recollection, well, if we get to it, we'll actually try it in a moment. So that's the basic syntax for H5 Repack. And then there are lots of things that you can do. First of all, yeah, you can print version information. So of course, since these command line tools like H5 Repack, H5LS, and so forth, they are distributed with a particular library version, and H5 Repack as a tool then uses that library version. So if you have 1.10.7 and you do an H5 Repack --version, actually let me do it quickly here. So if I do H5 Repack --version, it tells me, for example, I have a 1.10.7 library here, and it could be 1.8 something 22 or 1.12.0 for you. Now we are getting already into very specific options, and I'm not going to talk about them. It is very important, I think, sometimes when you have problems using the tool, by default, to be helpful or to be less confusing for users who use this tool for the first time, the error stack is actually suppressed. And you see that sometimes on the forum, somebody reports a problem that developers or help desk is asking you to enable the error stack just to get a better idea where when H5 Repack fails, well, it may just fail in a rather silent or uninformative fashion. So definitely, if you have problems, you want to turn on that error stack, because that sometimes tells you a lot more why exactly it's not behaving the way you think it should be behaving, or maybe you're looking at a corrupted file or something along those lines. So that's a very important option. Then there are options. Not only can you transform individual data sets or objects, you can actually upgrade the file as a whole in terms of, as many of you know, there is sort of an evolution of file of micro versions that sometimes together form what people call a version of the file format, although that is not really a well-defined thing. It's really families or collections of these micro versions make up something that gets distributed with certain library versions. And then if you want to call that a file format version, that's okay, although that's really not 100% accurate. But we'll maybe to talk about versioning, library versions versus file format versions is a good topic for another conversation, but not today. And then there are all kinds of options, right? Things that you can do with links, with copying behavior, with indexing. There's also some overlap here when it comes to user blocks, for example, there are in some cases tools dedicated to do just that thing. So in the case of user blocks, for example, there is a tool called H5Gem or H5Ungem. But unfortunately, many of these HDF5 command line tools, they have sort of a different genesis. They were sometimes developed specifically for certain projects, and people prefer, of course, one tool versus many tools. Although, if you think about the Unix philosophy, it's really the ability to combine and compose and so forth that together with the piping mechanism that gives you a lot of power and flexibility. With Unix tools, HDF5 command line tools have a tendency that things get duplicated and re-implemented, so they are not as orthogonal, and this doing one thing right philosophy that underlies many of the Unix tools, unfortunately, that is not how many of these tools are constructed. Anyway, you can play with alignment. You can reorder things, and then we are getting into we are talking about filters or compression methods as one example of filters. There are certain filters that come built into H5 Repack, like the usual, the gzip or deflate filter, the shuffle filter, the escapes me now. There are szip in some cases, depending on how your library was built and so forth. So there are several filters. And then layouts, again, you will have data sets in your HDF5 file, so you can take a contiguous data set, and in the output file, turn it into a chunk data set, maybe apply compression to the chunks, and then just see how does the file size change, how when you run it through your application that reads, for example, that data set, is there any change in the read performance? And the good news is this change in the layout doesn't really affect, you don't have to change your code, you don't have to change your application, because when you do an H5D set read, well, an H5D read, the H5D read will figure out how the data set is laid out in the file, and the library will do the right thing. You don't have to say, oh, read a chunk data set, or read, there are not separate read calls for all these different layouts. So the beauty is, again, you can experiment with this without changing your code, your application code. Then you can play with different file space management strategies and so forth. And I just put ... I think it goes on for another 2 pages at least, the options. What's more interesting is toward the end of this help section, there are some examples to use. So simplest case, for example, you can either apply some of these options wholesale on the entire file, meaning in particular all data sets in the file. So let's say you would like to apply gzip compression to all the data sets in the file. I believe since we can compress, for example, also groups or the link names in groups, off the top of my head, I actually don't know if this would apply gzip also to groups. It definitely applies to data sets. I'm not sure if it applies to groups. Again, something to try. I can report back next time. But then you can also customize this, and rather than saying, okay, I would like to apply gzip compression wholesale to the entire thing, to every data set in the file, you can restrict it and say, typically, or well, not typically, but often, you have one or a few data sets where you know they are big, and that's where your measurements or your physical, your heavyweight, your raw data lives. And then you have sort of auxiliary other data sets that represent connectivity or topology or something like that, then they are sort of, if you wish, metadata, application metadata. And you would like to compress only the measurements and so forth, but not the bookkeeping data, then you can restrict the application of, in this case, for example, SZIP compression with the appropriate parameters for SZIP to just one data set. So in this case, let's assume there is a data set called, or at a path /dset1, the slash is implied here. And then we are using verbosity that would ensure that, for example, H5 Repack would give us some information about compression ratio and so forth along the way. Then we can set the chunking, and as you can see here, you can do one kind of scheme for certain data sets and another type of scheme for other data sets. You can switch to you can switch the group layout again over the different generations of the HDF5 library. Initially, groups were B-tree based, but then there was a more compact way of, for small groups, small number of links, and you can again use H5 Repack to play with that. You can have, as we said, you can have pipelines of filters, so you can apply gzip on top of shuffle, and then you would provide these filter names on top of each other. And here's how to do that with user-defined filters. So if your filter is not one of the built into H5 Repack filters, as long as you have the shared library and you know the ID and the parameters, then you can also use user-defined filters with H5 Repack. And unfortunately, we are out of time, but this is an interesting topic. What I did here is basically, you can download this file from today's notes. This is just a simple piece of C code that creates two data sets. Each has 1 million elements. In one case, we generate just sort of the sequence 0, 1, 2, 3, 4, blah, blah, blah. And in the other case, we just generate a few random numbers. And then you can compare. You can apply the same kind of transformation, be it compression or chunking, and to the different data sets, and then see how the read time changes, how the size changes. That, of course, the sequential thing, it's going to be very easily highly compressible, and it's going to be relatively fast. But then what can you do? And it does, for example, the combination of shuffle plus gzip perform better than just gzip. That's very likely in this case, because we are creating random numbers in the interval 0, 1 that has a certain influence on how the mantissa, how the bits in the mantissa will behave, will be distributed, and the shuffle filter will detect that. And so, although these numbers are random in double quotes, we can maybe help the compression a little bit. But anyway, we are out of time. I apologize. But yeah, use this program, play with it. I'm sure you can write a Python script that's much shorter that creates you the same thing. But then, yeah, take a look at H5 Repack and play with it. And if you have questions, come back next time, and we'll definitely talk about H5 Repack and much more. Thanks for coming, and enjoy the rest of your day.